Hey Algebra 2, in this video we're going to be starting section 6.3, which is an introduction to logarithms. So before we talk about a logarithm, let's look at an exponential equation real quick. Exponential equation. So generalization, right, would be y equals b to the power of x. So b is our base, right? X is the exponent. And we can think of y as the product. And I'm going to call it a product because, right, if this were b to the fourth, right, it's going to be b times b times b times b, right? So we're multiplying it 4 times. All right, well, a logarithm. A logarithm is the inverse of an exponential function. So how do you get the inverse of a function? We did this in our last chapter. We swap the x and the y, right? So that would be b to the y equals x. But we haven't learned how to solve an equation like that. And so that's why we have a logarithm. So the definition, right, of a logarithm is log base b and the b is going to go down here, right below, like a subtext of x equals y. If and only if so the symbol means if and only if b to the power of y, b to the power of y equals x, right? So these are following the inverse definition, right? B to the power of y equals x is the inverse. But we have logarithms because this is hard to follow and we want it to equal y. So this means this, right? Make sure you know how to say it. So this is red, right? Log base b of x equals y. And this is read b to the power of y equals x. And remember, this means if and only if, which basically means the two equations shown are equivalent. Okay, you can go from one to the other. All right, so knowing this, let's do an example. All right, so rewrite each equation in exponential form. So the first one I'm going to do is log base 3 of 81 equals 4. So to rewrite this, the base of the logarithm becomes the base of the exponent. So my solution will be, let's do it in orange, we haven't used that yet. So my base of the exponent will be 3. And then it's going to be to the power of what it currently equals, right? So b to the y, so 3 to the 4th equals 81. Right, so rewriting this as an exponential. Let's do another one. Log base 7 of 1 over 49 equals negative 2. So rewriting this, I would take 7, raise it to the negative second power, and that's going to equal 1 over 49. Okay, so we're just following the definition of the inverse. So if I had, let's just do one more that kind of just generalizes it, right? So if I had log base a of r equals m, rewriting that as an exponential would be a, right, base a to the power of m equals r. All right, now we could also go backwards, right? So rewrite each equation in logarithmic form. And I'd encourage you to try to do this on your own. So why don't we do 5 cubed equals 125. Why don't you pause the video and try to follow the rules and write this as a logarithm. So as a logarithm, it's going to be log base, and our base is going to be whatever the base of our exponent is, so in this case 5. So log base 5 of 125 equals what's in the exponent. Let's do another. So let's do 2 to the negative 5th equals 1 over 32. So rewriting this as a logarithm, you could try to pause and do it on your own. So it'll be log base 2 of 1 over 32 equals negative 5. So the whole point of this, being able to rewrite it, now you're not going to really do it in this sense, right? We're going to use it for other kinds of problems you're solving, but this is just to make sure you understand this, right? If we're trying to solve for y, that's hard to do here, but we can solve using logarithms. So let's do that. Let's do some examples. All right, so let's just do an expression, not even an equation. So example 2. What is the value of each logarithmic expression. All right. So let's start with log base 5 of 125. What does that equal to? So there are two things you can do. One is just scrap work. So let's look at that. So for scrap work, right? Oops, scrap has a C in it. Fun fact. For scrap work, we could think of this as 5 to what power is going to give us 125. So 5 to what power equals 125? 5 to the third power, right? So as far as work goes, remember, these are inverses of exponentials. So how we would show this is log base 5 algebraically of 5 cubed. And log base 5 of 5, these are going to cancel out, so we know that this is equal to 3. And 3 is our final answer. So this is the way to think about it, and this is the way to actually algebraically show your work. So let's try another one. So let's do log base 1/4 of 16. So simplify this expression. So we're thinking, right, our scrap work, if we want a visual, or this is what you're doing in your head, is 1/4, right, the base, to what power gives me 16? So maybe you're thinking, well, I know that 4 squared is 16, but this isn't 4 squared, this is 1/4 squared, right? But remember, we learned that negative exponents, right, will invert it. So this will actually be 1/4 to the negative second, right? The whole thing to the negative second power, right? Because the negative will invert this to be 4, and then it'll be 4 squared. So what would that look like, for our work for simplifying this expression? We would rewrite this as log base 1/4. And you want your base here to be the base of an exponent here, because then they cancel. Right? So then these cancel, and our final answer is -2. All right, let's do one more. I'm going to do a challenging one. So let's do log base 3 of 0. Now let's do scrap work. So remember, we're thinking to ourselves, 3 to what power equals 0? Don't overthink it, right? 3 to what power equals 0? 3 to the first? No. 3 to the 0? No, because 3 to the 0 is 1. Is there any exponent that we can do that'll give us a value of 0? No. So this is just undefined, and that is possible. So log base 3 of 0 is undefined. Okay, there is no such power for 3 to whatever power to equal, oops, I almost wrote x, to equal 0. Right, so this is undefined.